Evaluating a massive enterprise security tool can feel a lot like this. You're facing countless streams of network information, dozens of complex features, and a nearly endless list of things you could theoretically test. When confronted with that kind of scale, most teams do what seems logical. They treat the proof of value as a feature-by-feature checklist, attempting to test absolutely everything in one go. But testing everything usually means proving nothing. It leads to slow deployments, noisy data, and ambiguous results that leave you unable to make a confident purchase decision at the end of the trial. A successful evaluation is not a general product demo. It is a highly disciplined, 30 to 60-day operational test focused on a specific problem. To maintain that discipline, you need to use a selection funnel. Think of all the platform's capabilities as raw potential sitting at the top of this funnel. Cisco Secure Network Analytics can identify crypto mining, detect data hoarding, or monitor encrypted traffic. But you cannot realistically validate all of those functions at once. You have to narrow the trial. A strong evaluation filters those dozens of capabilities down to 1, 2, or 3 highly specific, measurable outcomes. Prioritizing scope over clarity is a common mistake. Securing a definitive yes on your investment requires the discipline to ignore the nice-to-have features and focus entirely on your primary operational priorities. Achieving that focus means replacing ad hoc testing with a rigid chronological methodology. This is the 6-step timeline required to keep your evaluation under 60 days. Discover, deploy, baseline, investigate, measure, and decide. During discover and deploy, you define which network segments are in scope and which telemetry sources are available, ensuring your stakeholders are aligned before any software is installed. In the middle phases, you let the system baseline your environment. The team learns what normal looks like before they attempt to hunt for suspicious anomalies or policy violations. Finally, in the measure and decide phases, you formally document how quickly you retrieved evidence and how the tool integrated with your SOC, providing the facts needed for a final business call. Enforcing these 6 steps is the only way to prevent your evaluation from turning into an endless, resource-draining science project. Once the timeline is set, your chosen use cases dictate the exact telemetry and preparation you'll need, starting with threat detection. If your goal is spotting command and control communication or suspicious lateral movement that bypasses existing controls, you are evaluating the platform's ability to see what others miss. This requires an operational trade-off: precision. Evaluators must clearly define what constitutes a risky destination for their organization up front, rather than expecting the tool to guess internal priorities. Data protection is a different priority, focusing on identifying unusual data movement, massive transfers, or signs of internal data hoarding. The trade-off here is preparation. To prove this value, the team must map out their highly sensitive network segments before testing starts, so the tool knows exactly where to monitor for exfiltration. Selecting these use cases provides a clear window into your environment, delivering actionable visibility before a minor anomaly becomes a major incident. If your primary concern is network architecture rather than pure threat hunting, you'll focus on policy and segmentation. An evaluation can reveal whether theoretically isolated groups are actually communicating, highlighting unexpected access paths that exist in your production environment right now. This is where integrating Cisco Identity Services Engine, or ISE, becomes a priority. Adding ISE context enriches bare network flows with identity and device information, showing you exactly who is violating a policy. This level of detail is vital for hybrid work environments, where users often connect off-network or use split tunneling, creating massive visibility gaps for traditional sensors. The remote worker visibility use case solves this by deploying endpoint agents to a test group, allowing you to gather telemetry even when devices are off the corporate network. Testing these networking use cases validates your architectural goals, turning raw telemetry into proof that your segmentation and remote access policies actually work as intended. For SOC managers, the biggest hurdle isn't a lack of features, it's tool fatigue. Most operations teams refuse to adopt another standalone, isolated console. The SOC workflow use case addresses this by positioning the platform as an evidence engine for existing tools like Splunk, SIEM, or Cisco XDR. Proving this value requires coordination. You'll need to align your network and SOC teams during the evaluation window to set up the integrations and test the investigation workflows. Proving that an analyst can retrieve evidence without changing their daily routine is often a stronger indicator of long-term success than any single threat detection feature. Regardless of which use cases you choose, the most critical rule is this: explicit success criteria must be agreed upon before any software is deployed. Don't fall into the trap of basing success on finding an active, catastrophic breach during a 30-day window. That's a matter of timing, not a measure of tool effectiveness. Measure operational success instead, the ability to identify unknown communication paths, the speed of adding context to Splunk, or the validation of a segmentation assumption. To make your final decision, look at the results through a scorecard. Did you achieve the visibility you needed? How was the evidence speed? Did it fit your operational workflow? Using this scorecard framework eliminates open-ended technical debates. It forces a definitive, evidence-based business decision based on the goals you set at the beginning. Focused evaluations are superior because they are faster to complete, easier to measure, and provide a direct blueprint for a sustainable production architecture.